What is the distance of the ramp?
Displacement is our vertical displacement down the ramp. We said,
isn't that different than like how long the ramp is?
yeah, that's what different than how long the ramp is.
Isn't the distance that what we want? How long the ramp is?
Pretty sure it's down the ramp. This is our height of the ramp. Yeah. So velocity final is 2 times 3.35 times 5.1.
35. Hello, this is the V.
Would your D be negative or positive?
Yeah, I guess it would be. It would be a negative. Yeah, it'd be a negative.
Is that the distance to the bottom before it starts to incline, or the actual at the end of the instant?
We're saying just to the bottom. Displacement.
Okay, so he's just going from top to bottom. But
Top to bottom.
This is nothing to the actual limit.
Yeah.
Okay.
No. His velocity at the top of the ramp would be slightly less. It'd be a little bit less because he's going to lose some velocity going up the ramp. But we'll just assume for now that that's.
Oh, that's when he's going up the ramp.
Yeah, we're just going to assume that this velocity is what his final velocity is. Or.
We should assume that for all questions during this.
Yeah, you'll be given what it is off the ramp. So velocity final is negative. Second one.
Yes.
It's
It's negative going down the ramp, positive going up the ramp.
But don't the two negatives cancel each other out?
Negative and then positive.
The two negatives though, right?
Yeah,
Cancel each other out.
but then we took the square root.
So it would be positive.
Square root is plus or minus.
So you're just taking.
So we're using the minus because it's down the ramp, right? Velocity final, down ramp. Okay. This has nothing to do, or this isn't what you guys are going to be tested on. This is just to find.
So we're given this usually?
You'll be given this.
Uh,
Yeah. But we just needed this for this particular question. Okay?
no, the actual.
So velocity initial off the ramp is negative velocity final down the ramp. Does that make sense? So it's positive 5.8. That's where a positive and negative flip. Okay? It doesn't matter too much, but as long as you just have 5.8. And like I already said to Quinn, this is going to be given to you, your velocity off the ramp or your velocity fired or whatever. That's going to be given to you.
You mean the VI was like use the leaves around, it's going to be 5.8? Is that what you mean?
Yeah, when he's at that point, he's traveling at 5.8 meters per second.
That's his VI.
That's his VI.
We went down, and then apparently when we went back up, it's still maybe.
We're just, yeah.
And when he leaves it, it's still 5.8, and then he has to fall.
Okay.
But no. Why there?
Why there? Because that's right off the edge of the ramp.
I thought he measured from the top of the ramp.
Yeah.
Top where he leaves.
That is the top of the ramp,
That's the bottom where he's supposed to walk around from the bottom.
like that.
Yeah, so if there was 1.7, the top, very top where he leaves.
It is.
I'm
The
so
blue.
confused.
The blue is the ramp. This is just vectors.
Travel motion.
Oh.
Yeah. Yeah. So if you imagine this is the ramp, our horizontal displacement
Oh,
is
I got it.
1.7 meters, right? So now what we need to find is how far he'll his vertical displacement will be. Okay? So we need to find time, how long he's in the air for.
So, what's the question?
How far is he gonna land from the ground?
Okay, well, why do we need to? Oh, we just did that question where we just take dx.
So we have to find our velocity, our components, just like we did with when we throw the baseball, right? So Vy initial equals Vy sine 40, 5.8 sine 40, and that equals 3.7 meters per second. Vx is Vi cos 40. So it's 5.8 cos 40. And that equals to 4.4 meters per second. All right, so now we need to find the time. How long is he in the air for? So
Are we gonna try 2 times now?
no, we'll just have one time.
Just time.
Yeah. Time in there. So yesterday, or sorry, on Friday, when we were finding time in the air, what do we use for our displacement?
Oh,
You don't have to use
What was the question?
Yeah, on Friday, we had projected parallel to the ground, right? Like we threw a baseball, there was no displacement. What did we use for our displacement? 0. So now today, what are we going to use for our displacement?
1.7.
Negative 1.7, yeah.
Yeah.
To find our time. Right? This isn't any different from Friday. It's just now we don't have 0 displacement. So dy equals Vy initial time plus 1/2 at squared.
Can you do it without using that? Without using D?
No, because we need to find how long it takes
To go that far, or from that height?
from that height. Yeah.
So I can't just use the df equals di plus 18 for that?
No.
Wouldn't you need to do 2 times though? For when things like the curve and then the party with that?
I'm sorry. So our velocity initial is 3.7 positive because he's going up, plus 1/2 negative 9.8 is our gravity, and t squared. 1.7 equals 3.7 time minus 4.9 t squared. Bring it all over to one side. 4.9 t squared minus 3.7 t minus 1.7 equals 0. And we have to use quadratic. We have to use quadratic.
Why? It's 0.
How are you going to factor for t?
Oh, sorry, not sorry. So you already moved it to Y. I
Yeah.
thought it was already 0.
Yeah.
Okay.
Okay? So t equals minus b plus or minus b squared minus 4 times a c all over 2 times a. 3.7 plus or minus 3.7 squared, 13.69 minus 4 times 4.9 times plus 33.32 all over 9.8. Watch the square root. Oops. Plus or minus 6.8, 6.9 all over 9.8. So we have t equals 3.7 minus 6.9 over 9.8, and t equals 3.7 plus 6.9 over 9.8. Right? So the first one is going to give us this part right here, what the time is to this point. The second one is going to give us the time to that point.
So is that dotted line still going up there?
That dotted line is just imaginary. It's not actually.
Is it the raft though? No, you would stop.
What it would be, Jory, is if we threw from level with the ground. It's not actually existent, yeah. So we use this one, and we get t equals 7 divided by 9.8, 1.1 seconds. So he's in the air for about a second.
How did they vote for it?
3.7 plus 6.9 divided by 9.
Still have to do the other one to find out how long he takes from like. Did the curve so long even with the reps one guy to find the other one to find.
3.7.
What you gotta do is maximum height.
For solving for maximum height, we gotta find the time to get to that maximum height.
Okay, so
So plus 9.8 times time 9.8 time equals 3.7.
It's like 0.3 seconds.
Divided by 9.8 divided by 9.8.
So you just set VF to 0.
We set our final velocity 0 because we're finding, yeah, when he's at the top, his velocity is in the vertical direction is 0. So then our time is about 0.3.
And so we. So now we need here we get 0.3 equals 1 second.
We'd have to use, our velocity is changing, so we have to use the other one. Yeah, d equals vi plus 1/2 at squared. Vit plus 1/2 at squared.
oh, it's so cold in here. It's 18 degrees. You should get 22.
So 3.3.
I'd rather have 18 or sweater than have it like 27.
Oh no, I'd rather be shooting 27.
I like that.
We could be. I would do it.
So distance or displacement equals 3.3 times 0.3. We're point. Oh yeah, 3. Oh yeah, 3.7. Sorry. Yeah.
Way to mess up.
Way to mess up.
T equals
1.2. I usually answer them so
Because that's our velocity initial in the y, right? 3.7 times 0.3. Okay, but unless you got different.